For the past 3 decades, a single discovery in the field of physics created a massive unresolved question that essentially challenged our understanding of the entire universe. And that's because this one particular discovery that came out of Italy potentially suggested that we finally discovered what causes the idea known as dark matter, a mysterious substance that seems to make up approximately 85% of all mass in the entire universe, but that refuses to be discovered and whose mystery persists even today. Yet despite of this, many years ago, there was this one exciting discovery that potentially resolved everything, assuming it was correct. But because we're talking about the field of science, here these extraordinary claims required extraordinary evidence. Evidence that basically took over a decade to produce and that has now officially created a new mystery. And that's because science is always about consensus. And for years, this one specific experiment, referred to as Gamma Liberi experiment, presented us with a very strong claim that they seem to have discovered the dark matter particles. But the problem was that this experiment was so complex that it was just extremely difficult to replicate it, and we finally got the results from 2 separate teams in the last few months. And so today we're going to discuss these newly released results and the overall analysis of all of this, talk about these 2 new major experiments referred to as Anais 112 and Cosine 100, and basically discuss if this saga is finally coming to an end or if this is just the beginning of something entirely different. But I guess first, a super quick refresher in case you have no idea what I'm talking about. The refresher in regards to dark matter, and while its existence is known to us because of what we observe in regards to how it seems to affect everything around us when it comes to gravity. For example, by looking at various galaxies, we see that they seem to spin a lot faster than they should, as if they contained way more mass compared to what's seen in them. On top of this, various gravitational lensing effects and various clusters also produce gravitational effects that seem to be just a little bit too strong to be just explained with visible stars and hidden gas, because here the gravitational effects are much stronger and seem to be caused by something else. And so without some kind of an extra invisible mass, a lot of this is very difficult to explain. And so for many decades, one of the main explanations for this was the existence of some kind of an invisible particle, sometimes referred to as a WIMP. Weakly interacting massive particle, which would be, as the name implies, really massive, but would not actually interact with normal matter and mostly pass through it without any effect. In some sense, I guess kind of similar to neutrinos, but just way more massive. But occasionally, they can bump into the nucleus of an atom and produce a possible visible effect, which is what a lot of these experiments were kind of based on. And so back in 1995, a team of scientists in Italy started what's known as the Gamma experiment. And here, even starting in 1997, a team of scientists in the underground lab in Italy started to report something unusual. As they were observing the signals coming from their experimental chamber, instead of observing random signals, or basically what they actually expected to see, they noticed that the signals seemed to create a kind of a pattern that seemed to rise and fall with seasons. And while the explanation here was somewhat intriguing. Basically, as the Earth orbits the Sun, and as the Sun moves through the galaxy, the Earth is essentially flying through a kind of a wind of dark matter particles, where sometimes it sees more of them, and sometimes it sees less. For example, in June, we're moving much faster relative to that wind, and so the bumps would increase in number, whereas in December it was the opposite, and so the bumps would suddenly drop. And so here this Gamma experiment, in this case made out of sodium iodide crystals, seemed to record a lot more hits in the summer and much fewer hits in the winter, as if it was basically caused by this dark matter wind. With this even being reported with a ridiculously high significance of 12.9 sigma, which in physics usually means that, okay, there is definitely something going on here and it has to be investigated. Usually anything over 5 sigma is considered to be a definitive discovery. But I guess the question is, so why did nobody celebrate, and why did nobody announce this as the confirmation for dark matter particles? Well, apparently some scientists did celebrate, as this picture here shows us, but for a practically opposite reason. Because here we have new data coming from two separate experiments in two other locations that essentially find nothing. And that's because even back then there was a kind of an issue with other similar experiments that were already going on. Experiments like LUX and Xenon also initially found nothing, creating a new kind of a tension that could not be explained. But here there was potentially one explanation. A lot of other experiments actually use materials like xenon. And so here the argument was that dark matter for some reason might just have a special affinity for sodium and iodine and tends to bump into these crystals much more often. Which meant that this had to be tested, because if this is true, it would completely change everything when it comes to cosmology. And that meant that someone had to build exactly same setup with exactly same material, sodium iodide. And because this is science, all of the procedures and all of the experimental data was easily available for anyone to try to recreate. The problem was that this was a really expensive attempt and did require some very specialized equipment. But that's exactly what two separate teams were able to achieve. Here, Anais 112, that was now set up in the mountains in Spain, and Cosine 100, that was built underground in South Korea, for the past few years, essentially tried to recreate this in order to discover if they actually see the same bumps. And as a side note, that Cosine 100 experiment is only like 1 hour away from where I'm actually located. The problem is that nobody's allowed to go there, because just by visiting the location, you can technically completely invalidate a lot of the data. And so one day, it'd be fun to see what's going on there, but as of today, this underground location is going to remain mysterious. And so for years, these two teams collected a lot of data and tried to recreate everything as described in the original study. With the most recent studies released in 2025 and 2026, finally combining all of the data and creating a joint analysis that essentially tries to create as accurate of a picture as possible. And as always, you can find all of the relevant studies in the links in the description below. And so following this thorough analysis and years of data collection, the overall consensus is that there seems to be nothing that has been found, or essentially they found no evidence of any kind of annual modulation, or any kind of a bump, and any kind of a seasonal change. And by adding even more data from some of the more recent observations, the overall bumpiness seems to decrease even more. Or, I guess in plain English, these new detectors that use the same crystals and the same experimental setup seem to see flat lines instead of any kind of a wave. With the obvious question being, okay, so what is happening here and why is there such a discrepancy? Well, if dark matter is not causing the gamma signal, there has to be something else that's going on, with new studies now suggesting that this could be some kind of a statistical artifact or maybe some kind of a background noise that's not accounted for. With at least one other study even trying to take a look at maybe some kind of other physical effect, or even some new physics going on here, that could potentially explain both results at the same time. And intriguingly, the discovery here also suggests that, in some sense, all three experiments seem to actually be correct, despite having results that don't match. With one potential explanation being, maybe this is actually something to do with chemicals used and their overall response to seasonal changes. For example, maybe the iodine atoms used seem to create additional peaks in the winter, with the sodium atoms peaking in the summer. Although in this case, this explanation still doesn't really make much sense, because here it's just unlikely to happen in such a way where the other two experiments were not affected. In other words, the conclusion right now is that, well, the two recent experiments discover nothing, but that first experiment seems to have still discovered something we still do not understand. In other words, the claim for dark matter particles is not very strong anymore, but there could still be some kind of a physical effect discovered in the original experiment that just does not have a good explanation yet. And well, the thing is, it might remain a mystery for quite some time, because these additional experiments have now been officially concluded. As a matter of fact, that's exactly what these scientists are celebrating. They've now finished the experiment, and as of January of 2026, began dismantling everything because their mission here is complete. In other words, for the scientists behind the Anais 112 study, the one in Spain, they agreed that they seem to have just enough data to definitively say that the gamma signal was extremely likely not dark matter, or at least not dark matter represented by weakly interacting massive particles. And for science, this is, I guess, good news because it sort of removes a kind of a long-standing obstacle that confused the cosmological field for the past 25 years. In other words, based on these studies here, we can now stop trying to force our models to fit this anomaly and instead focus on new candidates and new explanations. Because for all we know, the Dama Libre experiment just had some kind of a statistical anomaly. And the thing is, because a lot of these experiments focusing on WIMPs or weakly interacting massive particles have now been basically finding nothing, a lot of cosmologists and a lot of physicists have now been switching to additional explanations, with the most accepted new explanation being the idea you can learn about in one of the videos in the description referred to as axions. Essentially incredibly light particles that seem to act more like a field or a wave and not as a typical particle or a grain of sand. Or alternatively, maybe Stephen Hawking was right, and it's all just a bunch of primordial black holes. Now, as we've discussed in one of the videos in the description, at first there was a potential discovery of such a black hole in a nearby galaxy, but that turned out to be possibly incorrect, and once again you can learn about the explanation in the video right there. Which I guess, in a sense, brings us back to where we were a few decades back. We still have no idea what's going on, there are still a lot of unanswered questions in cosmology, and the search for dark matter continues. But even though the mystery of dark matter remains unsolved, that Dama anomaly has now been officially resolved. And in this case it was done precisely how it should have been done, by trying to recreate the same experiment in two separate locations, and by essentially discovering nothing in the process. Science at work. And so here, the anice and cosine collaborations show us the power of scientific method. The method that contains this self-correction mechanism. But I guess until we have some new discoveries about dark matter, or until someone else proposes something else interesting, that's all we have. We'll come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.